Okay, so two things we want to do. First, I'm realizing that I forgot to show you for the second example, the 2x squared minus 12x minus 25 example. So in the previous problem, we set it equal to -6, and we solved from there by completing the square. But we also want to see if we wanted to put it in the vertex form, because it's the other thing we use completing the square for. Right, so now previously we could just divide everything by 2 and with no repercussions, right? Now when we do that same thing of dividing by 2, because we still want a to be 1 for us to complete the square, it'll just be easier that way each time, right? So I can have y over 2 is equal to squared minus 6x minus 12.5, right? So now I'm going to have y over 2. So minus 6x. So same thing, I'm going to do plus 9. I can either do plus 9 minus 9 just to make it 0, or I can do the plus 9 over there, but like eventually you'd end up subtracting it over, so we might as well keep it here. Great. And we still recognize that that is the square we have completed, right? So now y over 2 is equal to x minus 3 squared, and now that's minus 21.5. But now we still want things as y equals, right? Because that's what means something to us in terms of functions that we can recognize. So 2 minus 3 squared, sorry, that's ugly, minus 43. Okay, so now we see that key things, both things get multiplied by 2, right? So this is now negative 43, and also we need to always get it back into y equals form, and this is a parabola that faces up that has been stretched by a factor of 2, so an a value of 2 with a vertex at 3 comma negative 43. And we can even check that, right? So if I plug in positive 3 into here, then I get 2 times 3 squared, so I get 18 minus 12 times 3 minus 30, whoops, ugly 3, sorry, minus 36 is negative 18 minus 25. That goes to, oh, no, sorry, equal sign. That equals negative 43. So I can feel good that at least 3 comma negative 43, my new thing in vertex form, is a point on the original one. Yeah, and that's pretty much it. So now, the main thing this is for is quadratic formula, right? So when we have this, y is equal to ax squared plus bx plus c. This is just standard form, right? If we wanted to complete the square, I would say y over a is equal to x squared plus b over a x plus c over a. So far so good. So now y over a is equal to x squared plus b over a x. Right, so how do we find the thing that we want to add on? We divide this by 2. So b over 2a, and then square it, right? So plus b over 4a squared. Good. Minus b, sorry, plus b squared over 4a squared minus b squared over 4a squared. And then still plus c over a. So now we agree this is the thing that we are completing the square for. Y over a is now equal to x plus b over 2a squared, right? That's just this from us completing the square minus that. So let's see, we want a common denominator, right? So c over a is the same thing as 4ac over a squared, right? Oh, sorry, over 4a squared, right? This is just c over a with that. So now that just becomes plus c minus, what am I doing? Sorry. Yes, I'm very tired. I am not going to remake this video because who has the time? Minus b squared. And this is a plus 4ac, so if you want it to become part of that, so then the minus distributes, right? Also, guys, this should look really familiar. Not quite yet, maybe, but anyway. And now we have to multiply the a back through. So y is equal to a times x minus b over 2, plus b over 2a squared AC over 4a, right? Because we multiplied everything by a, so now, great. So, first of all, this is just vertex form with those. This doesn't really tell us anything unless this is how you wanted to construct vertex form out of standard form instead of just completing the square. I think it'd be way easier to complete a square than to just use these variables. But this is interesting when we said y equal to 0. And we said y equal to 0 because we're looking for x-intercepts, right? So that would be solving the actual equation. So we have boom, boom, minus, keep doing that, squared, 4a, right? So now I can move that over, and I have b squared minus 4ac over 4a is equal to a times that. I really hope I don't mess this up. Sorry, I mean, I'm super confident. Divide by a, I'm gonna move this side over. X plus b over 2a squared is equal to, now I've divided that back by a, b squared minus 4ac over 4a squared. Take the square root. So x plus b over 2a is now equal to square root of b squared minus 4ac. There's no easy way to put that, or like no simpler way to put that, sorry. And then the square root of 4a squared is just 2a. And again, plus or minus. So now, isn't x just equal to negative b plus or minus the square root of b squared minus 4ac all over 2a, right? Same denominator, I can combine them. So now this is our quadratic formula, which is true when we set the equation equal to 0, because these x values, the two that this spits out, now tells you your x-intercepts from standard form. And now also one thing is that if we understand that the vertex or axis of symmetry is at the midpoint of any 2 points with the same y value, including intercepts, then that means the midpoint of these two is where the axis of symmetry is, or the vertex. So that's just the negative b over 2a part, because this plus or minus will cancel itself out. And the other place where that shows up is when we just completed the square the first time through as a function. Doesn't x plus b over 2a now imply that the vertex happens at negative b over 2a? So now we have a way of, I'm going to write that somewhere here. So now you have a way of figuring out where the vertex is from standard form, even without having to fully go through the steps of completing the square, right? So you'll only need to complete the square if you're converting something to vertex form. But if you just want to find the vertex, this is the x value. Oh, that's x value of, right? And now the y value, yes, is this ugly thing, or you can just evaluate this, whatever it is, and plug it back in, which is what we did with this earlier problem, right? Instead of completing the square for all of this, to find that the vertex is at 3, negative 40, I could have just done negative b over 2a, so negative 12, positive 12 over 2a, 4 is 3. My vertex happens at 3, I can plug 3 back into this function to get 43 out. So that's just one example where this applies. You can try it with your other ones. Hopefully you also see that, like, this is a great shortcut to know. This is often excessive, so you don't need to break out the quadratic formula, both because often there are easier ways and also for interest of time, I guess. Yeah, give these some practice. Again, email me if you have any questions.